Good afternoon. Today we're going to talk about congruence in triangles. And our main objective is to identify and use corresponding parts of figures and to apply the third angles theorem. You can find information on this in your textbook, pages 216 to 220. So if we think about some rigid motions that we have studied translations, we have talked about reflections, and we have talked about rotations. And if we think about why these are considered to be rigid motions or isometries, the thing that they do is they preserve angle measure and they preserve side length. So when we slide a figure or we reflect a figure or we turn a figure around a point, we are not changing the lengths of the sides and we are not changing the measures of the angles. And if we think about the one transformation we studied that was not a rigid motion, that actually changed the side lengths, it didn't change the angle measures, it only changed the side lengths. But the last section in the previous chapter, when we did dilations, we enlarged figures and we reduced figures, which actually changed the lengths of the sides. So now, if we think about a rigid motion maps a figure, or each part of a figure, to a congruent part of its image. And because rigid motions preserve two things, they preserve length and they preserve angle measure, the corresponding parts of all the congruent figures are going to be congruent. So what does that really mean in English? If we look at example 1, and it says to identify all pairs of congruent corresponding parts, and then write a congruent statement for the following polygon. Is letter order important when writing the congruent statement? Yes, letter order is always important because it identifies the corresponding congruent parts. So I tend to always start with the hashes, and I'll start with the 1 hash. So you have a 1 hash here at B and you have a 1 hash here at L. So that tells us that angle B is going to be congruent to angle L. If I look here, I have 2 hashes here and I have 2 hashes here. So that tells me that angle A is going to be congruent to angle M. And continuing around the triangle, I only have 1 angle left. It has 3 hashes, so angle C has 3 hashes, and it's going to be congruent to the angle in the other picture, which also has 3 hashes, which in this case happens to be N. Then you're going to look at the side lengths. So right here, AB only has 1 hash, and ML only has 1 hash, so that means that segment AB is going to be congruent to segment ML. And yes, it's important that you use the congruent sign. We have no idea what the actual lengths of these segments are. All we know is that they have the same length. So then I'm going to come over here. I'm going to look, I have 2 hashes here, and I have 2 hashes here. So that tells me that side AC is going to be congruent to side MN. And last but not least, I have side BC, and it is going to be congruent to side LN. Now, how do I write my congruent statement? I will tell you, I will always go from my 1 hash to my 2 hash to my 3 hash side. So here, angle B has 1 hash, angle A had 2 hashes, and angle C had 3 hashes. Then I go to my second triangle and I do the same thing. I always go in the same order. It keeps me from screwing up and it keeps it very consistent. So angle L had 1 hash, angle M had 2 hashes, and angle N had 3 hashes. Now, could you write that other ways? Yes. If I wrote this one as CAB, I could write this one as NML. I could start with letter M or start with letter A. I could go ACB, which means over here you would have to go MNL. So as long as the corresponding angles are the same, I can look at this statement and I can take the second letter here and I can go the second letter here. And when I come over to my pictures, A and M should have the same symbols. So you can look at those congruent statements and tell what parts are. All right, let's look at example 2. It says to mark all the corresponding sides and angles congruent if triangle BDC and triangle MLK are congruent. So if I start with the angles, the first letter here is B, the first letter here is M. So I'm going to mark angle B congruent to angle M. And then moving on, Second letter here is D, second letter here is L. So that tells me in my picture that angle D is going to be congruent to angle L. And last but not least, you have angle C and you have angle K. So angle C is going to get 3 hashes and angle K is going to get 3 hashes. Now, going to my sides. If I look at my first 2 letters here, I have BD and here I have ML. So this tells me that BD and ML are going to be congruent. If I go to my second set of letters, here I have DC, here I have LK, so DC is going to be the same as LK. And last but not least, I'm running out of colors. Yellow is not the greatest, but here I have BC and here I have MK. So down here, BC and MK are going to be the same. All right, so that's what it would mean. Use your congruent statements up here. It will really help you. And yes, that letter order is super important. So BG. So BG, if I look at these 2 quadrilaterals, they are not oriented the same. They have been rotated. This is when I really use my congruent statement. So if I come up here and I look at BG, BG is letter 2 and 3, and over here, DE is letter 2 and 3. So that means that BG and DE are going to be congruent. So DE is going to go right here. If I look at angle H, so angle H is the 4th letter here, F is the 4th letter here, so that tells me that angle H right here is going to be congruent to angle F right here. So angle H is going to be congruent to angle F. So looking at FE, so FE occupies the 3rd and 4th spaces of this statement. GH occupies the 3rd and 4th statements or locations of that statement. So GH and EF are going to be congruent. I think these all need segment marks. Okay, angle A. So looking again at my picture, angle A is right here, but if I look at my statement, angle A is my first letter here, angle C is my first letter here, and if you look at the picture, both of those are right angles, so that should help narrow that down. And finally, FC. FC are the first and the last letter of this statement, so if I look at the first and last letter of this statement, it is AH, so that tells me that AH is going to be congruent to FC. All right, the last thing they ask us to do over here on the right is find X, but because I know that angle H and angle F are the same, I can come up here and set up my algebra. If you do your homework and you do not set up this step right here, I will give you 0 points on your entire assignment. That is really tells me that you know what you're doing. If you have an answer only, as always, you will not receive credit. All right, moving on to example 4. Example 4, they want us to find X and Y. So first things first, if I want to find X, this side right here is side QR, which is the 3rd and 4th letters here. So if I look at the 3rd and 4th letters here, it is side FG, which tells me essentially that 12 is going to equal 2x minus 4. To set up my other equation, to find Y, I'm going to look at angles. Here I have angle Y, so I know that angle Q is the 3rd location here. Angle F is the 3rd location here. So that tells me that these 2 statements are going to be the same. So I know that 6y plus x is going to equal 68 degrees. Because the equation over here on my right has 2 variables, I'm going to have to come down here and find x first. So just take a minute, do your algebra, and find x. Once you complete your algebra, you should realize that x equals 8. So I'm going to come up here to this equation. I'm going to plug 8 in for x. And then I'm going to continue on with some more algebra to find y. All right, so after completing your algebra, you should realize that x equals 8 and y equals 10. All right, example 5. Example 5 says, what information would you need to make the two triangles congruent? Justify your reasoning and write your congruent statement. So by looking at this picture, I can really write a congruent statement because I know the three sides are congruent, but I need to know all 6 parts are congruent before I start that. So I need to show that my 3 angles are congruent. Well, the good thing is, if I remember back to the very beginning of geometry, I learned that vertical angles are congruent. So angle PTS is going to be congruent to angle QTR because vertical angles are congruent. The other thing I really have to look at here is the fact that when I look at this picture, they told me these 2 lines are parallel. And when I have 2 parallel lines really allow me to use that magic Z. So if I think about my magic Z, I can come in here and I can say, all right, you know what? If I make my Z go along like this for my magic Z, what that tells me is that this angle here, that this angle here and this angle here at Q are congruent. So angle S is going to be congruent to angle Q because if you have 2 parallel lines, then alternate interior angles are congruent. If I take my magic Z to a new level and I do my magic Z twice in the same picture, I could come along and I could go this way for my magic Z. And when I do that, that tells me that this angle down here at R and this angle down here at P are also congruent. So I'm just going to add that over here, that angle R is congruent to angle P for the exact same reason. If 2 lines are parallel, then alternate interior angles are congruent. So if I want to write my congruent statement, I always go with 1 hash, 2 hash, 3 hash. So if I look at my angles with 1 hash, those are both angle T. So my congruent statement is going to look like this. Triangle T, and then I'm going to proceed to my 2 hash, S, right here. And then I'm going to proceed to my 3 hash angle P, and that is going to be congruent. Go to the triangle on the right, find the angle with 1 hash. It's right here at T. Go to your angle with 2 hashes, Q, and go to your angle with 3 hashes, R. And that is how I will always write those congruent statements. The third angles theorem. The third angles theorem has to do with the angles of a triangle. So let's look at what it says. It says that if angle P is congruent to angle X, so I'm going to come down here on my picture and I'm going to mark P is congruent to X. And it also says here that Y is congruent to Q. So Q and Y are the same. So basically what we can think about is if I assign angle measures to these angles. So let's say that P is 100 degrees. That would also make X 100 degrees. We'll keep this pretty simple. Let's say Q is 20 degrees. So here Q is 20 degrees. So if I think about finding R, 100 plus 20 plus angle R is going to have to add up to 180. And over here, if you take 100 plus 20 plus angle W, that has to equal 180. And if we figure out what angle R is, angle R over here is going to be 180 minus 120, which is 60 degrees. And over here on the right, if I find angle W, 100 plus 20 is 120. And if I subtract 120 from 80, or 180, I also get 60 degrees. So basically, if 2 angles of one triangle are the same, then the third angles of both triangles also have the same measure. So in this case, angle R would have to be congruent to angle W. And that's what the third angles theorem says. It says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. All right, that's it for today. I hope you have a wonderful afternoon, and I look forward to seeing you in class tomorrow.